All right, we are live on YouTube Vertical. We're about to be live on TikTok. And then let's go live on YouTube Horizontal. No idea if this is going to work, but let's try it. All right, so we are live on YouTube Vertical, I think. Hopefully everything's good there. I'm working to get YouTube Horizontal up and running. We don't yet have it set up. I don't know why it's not working. Video. Why is 6 afraid of 7? 6, 7. 6, 7. No, I don't actually know what the 6, 7 business is about. Well, I guess we'll see. So YouTube Horizontal seems like it's not working. Don't understand why. Well, okay. I mean, we'll just see how it goes, I guess. We'll just do vertical for today. I'll figure out horizontal later. Anyway, I hope everybody's having a good day. I hope everybody can see me. Everybody can hear me all right. This is not a debate stream, Hugo, so it's not really relevant to the point you were making. Let's put this back in the center. How's my recovery going? Much slower than I'd like it to be honest. I feel like it should be better by now. It's been like over a week, but such is the nature of getting sick, I guess. It's really not fun. Why can't I see the fan funding? Okay, well, whatever. It's not super relevant. Okay, let us, right. Well, let's get into the questions anyway. Right. What are your credentials? I'm curious. I have a PhD in physics. I'm published both in physics and mathematics. Seems like it should be enough. Do the questions have to be solely physics, or can they be generally science-based? Well, keep in mind that I don't know. I'm not an expert in biology. I'm not an expert in chemistry. So if you ask me general science questions, I will answer with my general science knowledge, but I won't. Perhaps might not know the answer. What are the chance of existence is, okay, I don't know what that question means. Do you believe in time travel? We can travel forward in time, no problem. The question is can we travel back in time? That's the hard part, right? Let me shut my door really quick. Is time just a measurement created by humans? Plausibly. The thing is time is a feature of our universe. Now the question is what kind of feature? Is it fundamental or is it emergent? That's the serious question. Did I just start stream? Yeah, I just started stream. Any words of advice for my algorithms test in an hour? Oh, I can't help you there. What do you think about flat earthers? They are good free content. By the way, make sure to like the live, follow, subscribe, ring the bell, all of these things. That way then you can see when I'm doing these lives more. Also, there's a Discord server that you can join with links in the various places, Linktree, description, where I send out announcements for these. So that's also helpful. What came first, the laws of physics or atoms? Well, yeah, laws of physics definitely came first, insofar as like the regularity that could give rise to the laws of physics existed before atoms did. What do you think about Breaking Bad? I thought it was a good show. What's inside a black hole? At this point, we don't really know. There are speculations, of course. Those speculations look something like, well, maybe there's an ultra-dense core that's not infinitely dense, or maybe there genuinely is a singularity, but we don't really know at this point. What made you change from being a postdoc to a content creator? Oh, well, I mean, like, in some sense, my postdoc contract ended. I'm applying for more postdocs now. In the meantime, I'm doing science communication because I can make money this way, and I like doing it. And it gives me enough time to still do research and still focus on my academic stuff. Postdocs are temporary positions, right? So the postdoc I had was 2.5 years, and then it was over. Now I'm applying for more. Time to get raptured. Yeah, that'll be funny. What's the chance of existence if there are many miracles happening? I don't think that there are miracles happening. What do you think of people named Will? I think it's a fine name. But please stop spamming. If you're spamming, I'm not going to answer your question. Have you done any group theory? Yeah, I do plenty of group theory. Well, okay. I should say that the group theory I do is more representation theory, which is closely related to group theory, of course. Is there a limit to how many postdocs you can do? Not in principle, but generally they're not looking to hire 40-year-olds or 45-year-olds for postdocs. It's just like younger people tend to be more promising. Double slit experiment explanation. Yeah, so you take a photon, you pass it through something called a nonlinear optic. It splits into, well, actually, yeah, you can just take one photon really if you want. You send an optic, or you send that photon through two very, very narrow passages, two slits. If you don't do anything to it, then when those photons hit the screen behind the two slits, what you'll get is a wave pattern interference. You'll get a wave interference pattern. So it'll look like this. You'll have dark spots and bright spots interspersed. However, if you then somehow get which path information about which slit the photon traveled through, well, then you only get single pattern interference, which just looks like a bright spot surrounded by a few dark spots surrounded by a few bright spots. Now, it turns out that this happens as a result of interaction. At least that's the mainstream explanation, that if you interact with a thing, then of course you're going to change its behavior. When you interact with it, you're basically forcing it to take on the property of the thing that you interacted with. You're forcing it to match the properties of the thing that interacted with it, meaning that, and if the thing that you interacted with it is classical, if it's macroscopic, then it's going to have to take on macroscopic-like behavior. It can't be in a quantum superposition anymore. So that's essentially one explanation. Are you a smoker? No, I just have a cold. So James Webb looked far out, just found more universes. Is that from light bending? Universes round. So it hasn't found more universes, it's found more galaxies, but we kind of expect to see more galaxies. By the way, if you're watching on YouTube or TikTok, make sure to like the live. Very, very helpful. If time is relative, can we ever really escape the first cause? I don't know what you mean by that. What's the best reading you've come across that explores the origin of the universe? I don't think that there is a best. Oh, I need to send an announcement. I'm sorry. I don't think there is a best. We don't have enough data yet to know what the correct answer is. Can you tell me how the hydrogen energy works? Well, so hydrogen is a chemical, and you can burn it. When you burn something, what you're doing is you're combining the chemical with oxygen, and that's an exothermic reaction. So you combine hydrogen with oxygen, you get water vapor in particular, and it releases a lot of energy. And you can take advantage of that. Do you have an idea why 3I Atlas's tail is in front of it? Yeah, this is something called sublimation. Essentially, the part of the comet that was in front, that was facing the sun, vaporized and produced some gases. Wait till bro finds out about quant trading. Nah, I'm good. General explanation of the weak force. The weak force has kind of two pieces. One piece is what's called the neutral current piece. And this is a lot like electromagnetism, it's just a weaker version of it. Namely, it can cause attractions, it can cause repulsions. And that's basically it. It's just like a weaker version of the electromagnetic force. Then there's the charged currents. The charged currents are more like transmutations than like forces. Basically, you can have a W boson, which is the carrier of the weak nuclear force, combined with an electron, and it changes it into a different kind of particle, into a neutrino, for example. So it kind of has these two different faces, And the reason why it has a piece that behaves a lot like the electromagnetic force is because the electromagnetic force and the weak nuclear force used to be the same thing, the electroweak force. What are your thoughts on nuclear energy? I think it's very valuable. I think that we should absolutely take advantage of it. How much do I have to donate for a greased up twerking stream? I don't know if you could donate that much, donate enough. There are some quantum physicists that now think that there was never a Big Bang. In truth, it was really just a placeholder until we could have a better explanation. This is actually like the mainstream explanation. More specifically, the mainstream explanation is that the Big Bang has nothing to do with whether or not the universe had a beginning. Rather, the Big Bang is a description of what happened about 13.8 billion years ago when the universe went from small to large. But it doesn't say anything about that being the beginning or anything like that. For fine-tuning, is it only epistemic, or do we know some constants are variable? It's only epistemic, at least this far, at least at this point. Thank you for the $5, Ifan. Thanks for all you do. You're a great science communicator. I appreciate that. How far from fission are we to actually practically using it? We already use fission. You're probably referring to fusion. So nuclear fusion is the process by which you combine elements. You make two light elements into one heavier element, and you get energy out. That, who knows? We've been saying it's 30 years away for the last 40 years. Maybe we'll never get there. I am confident, though, that progress is being made, so I think it'll happen eventually. It's just a question of when. Oh, I'm sorry. And I'm toying around with the idea, I'm toying around with how you would go about proving this in the back of my head. I have some ideas. I just haven't gotten around to writing it down yet. In magnetic, sorry, I have to mute somebody. Oh, wait, for some reason I'm not like, that's why. Sorry, give me just 1 sec, okay? I need to sign in on YouTube to my YouTube account because that's why it wasn't doing what I wanted it to do. No, stop it. Stop it. And now I can pop this out. There we go. Good. Okay, sorry about that. Can entropy decrease if combined with randomness an infinite amount of time? Yeah. And the second law of thermodynamics is a statistical law. Can you explain the delayed choice experiment? Yeah, so it's hard to, like, I don't have it fully internalized, so I always have to go back and check my notes. But roughly the idea is that there's nothing that really implies anything about retrocausality unless you assume that the system is classical. But the system isn't classical, it's quantum, that's the whole point. So this is all to say, the delayed choice quantum eraser experiment is interesting, but it doesn't prove anything about retrocausality. Now, I actually think I'm going to add to my to-do list that I should go and remake that video because I have an old video on it and I think it's pretty good, but it's a bit outdated. It's not like up to my typical standards anymore. So I'm going to remake it so I can refer people to it. What do you have a PhD in specifically? My PhD is in physics. I specifically work on conformal geometry and relativity. Can you explain why scientists built CERN? Yeah, so the intent of CERN was to find the Higgs boson. So the Higgs boson was a particle hypothesized by Peter Higgs and a few others back in the 60s and 70s. And if the Higgs boson existed, then it would basically complete the standard model of particle physics. We knew about the strong force, we knew about the weak force, electromagnetism, but there was still kind of a piece that was missing, which the Higgs boson, if it existed, would fill that gap. And we hadn't found it up until a certain point, up until like the 90s. And so starting, I guess, in the 90s, they started building the Large Hadron Collider in CERN. I think it was in the 90s, with the goal of finding the Higgs boson, and they did. Would it be possible for a star to have enough mass where the light it emits curves back? That's called a black hole. Yeah. For From a physics standpoint, can you explain why No. Why can't stronger magnetic fields alone prevent plasma instabilities in fusion reactors? I think the issue is that we just have trouble making strong magnetic fields. There are some more complicated physics issues, though. Which I'm not familiar with. Have you watched K-pop Demon Hunters? Yeah, it was really good. But before a black hole, light that is curved, but not inward. Well, yeah. So all light leaving a star, it doesn't curve inward, but it is kind of dragged as it leaves. And this is called gravitational redshift. What, if anything, do we actually know about dark energy currently? I read something about that in relation to an uneven expansion of the universe. So as it currently stands, what we know of dark energy is that it is the thing that is driving the accelerated expansion of the universe. Now, the question is what is it? Well, that we don't know. However, recent data coming, I guess, starting in, that was released in 2023 and then more in 2024. Sorry, was it? No, I think more came out in this past year, didn't it? Anyway, recent data came out that indicated that whatever is causing the acceleration that thing apparently is decreasing. We don't know how or why. We don't know a lot about it, but we do know that whatever it is, it's causing the accelerated expansion of the universe. Could life still exist if planets, could life still exist if planets like Earth was floating about in space? So it's tricky, right? On the one hand, there is an internal source of energy that the Earth provides. This is in the form of nuclear energy, essentially. There's uranium in the core of the Earth and in the mantle, and that decays and produces heat, but it's not very much. So I suspect probably not. Can you change? Oh, that's not a question. By the way, if you're asking your question over and over again, please wait 5 minutes before asking. Otherwise, it just looks like you're spamming. What is the reality of antimatter? Is there any antimatter we can see visually? What's practical versus just math? Well, look, so antimatter is real. We can make it. We make it in laboratories pretty regularly. In fact, we know that bananas emit antimatter. So antimatter is absolutely real. Absolutely a thing. The trouble is it just doesn't last very long, because if you take antimatter and you put it next to regular matter, they blow up. And so it's really hard to store for any extended amount of time because there's matter everywhere. But yeah, it absolutely exists. It's not just math. It's just we can't make enough to see it. It's just too small an amount. Do you believe in an objective reality, and why? Well, I mean, sure, I guess. I think that there's a universe. How close are we to finding evidence of parallel universes? I don't think they would need to exist in order for us to find evidence of them, and we don't have any reason to think they exist. Theoretically, could life acting on the universe lead to entropy decreasing? No. Life doesn't really have any special relationship with entropy. Do you think magnets could be used against each other to create propulsion for future aircraft? No, not how it works. Magnets aren't magic. Did you just say bananas are antimatter? No, bananas produce antimatter. Bananas have a lot of potassium in them. Anything with potassium, we'll do this, but bananas have a lot of potassium in them. And one of the ways that potassium, and in particular, it has a particular radioactive isotope of potassium. And one of the decay patterns of this radioactive isotope of potassium is that it emits an antimatter electron about once every 40 minutes or so. From Eric Mishima with the $5, what's the difference between physical and material? It's vague. I mean, that's a philosophical difference. I mean, physicists wouldn't really make a distinction. You might say that material is stuff made of matter. And for example, the electromagnetic field is not made out of matter, it's made out of bosons. So maybe you would say that photons are physical but not material. Are you aware of topological superconductivity? Apparently Microsoft brought it to reality. This is super old news. This is over a year old news, and they just made this shit up. It's not real. The thing causing accelerated expansion of the universe is decreasing. Will it stop expanding? That's what we don't know. It's possible, though. Are we able to create element 115 now? Yep, and it isn't special. It's not stable at all. When antimatter blows up, do they disappear completely? Well, so they disappear, and then they basically annihilate each other and turn into light. Sorry. Is quantum computing a pipe dream? No, we have quantum computers. They exist. How does the weak nuclear force work? Yeah, so the weak nuclear force has two parts. There's one that's a lot just like a weaker version of the electromagnetic force. And then there's another one that kind of does a transmutation. So the weak nuclear force can cause an electron to turn into a neutrino, for example. Or it can cause one quark to turn into another kind of quark. So it kind of has two branches. And the reason why one of the pieces is a lot like electromagnetism is because the electromagnetic force and the weak nuclear force used to be the same thing. I feel like black holes could be a key to our understanding of the universe and the Big Bang. Do you think they could be part of the fundamental structure and dynamic of the universe spacetime? Maybe not fundamental structure and dynamic of the universe, but learning about black holes, if we understand black holes, then I suspect we will understand a lot more about the universe than we currently do. Particle antiparticle annihilation can have final states other than photons. That's true, but the most common final state is photons. What's the difference between a magnetar, neutron star, and a black hole? So a magnetar is a type of neutron star. It's a neutron star with a very, very strong magnetic field. A black hole is just a different object entirely than a neutron star. A neutron star is basically like a giant atomic nucleus, super, super dense, but you can still see it. A black hole is so dense that even light can't escape, so you can't see it. Is it theoretically conceivable that the angular momentum of a rotating black hole could be increased, for instance, via directed laser radiation to the extent that centrifugal forces destabilize it? What you're talking about are called super extremal, or there's a, it's not sub-extremal. Maybe it's super extremal black holes. These are black holes that are rotating faster than what we would call an extremal black hole. An extremal black hole is rotating so fast that it no longer has an event horizon. You just have a naked singularity. And people have thought about this, but we don't currently have, as far as I know, there's no current way even theoretically that we know of, that we can make this happen. Also, there's probably good reason to think that naked singularities can't exist. $5 from Neck2 for some throat lozenges. Hope you mend ASAP. Yeah, me too. I'd really like to not have this awful throat thing. I want to know more about the expansion of space. Do you think we can manipulate it? No, we can't manipulate it. No more than we can manipulate gravity. I mean, we can manipulate gravity by just moving things, but we can't really manipulate it in like some fancy way. Unfortunately, you know, it's just the way of the world, I guess. What really is the spin of a particle? It's just a fundamental property of the particle. Particles can have charge, they can have mass, they can have angular momentum. It's just it's a property of the universe. Do you ever have to Google something? Yeah, sometimes. Can we get to a point where we can use antimatter for energy? Probably, look, so you'll never get more energy out than you put in from antimatter, because to make antimatter is very, very energy expensive. However, if you could use antimatter as like an energy store in principle. You just make a bottle, you put the antimatter in it, somehow protect it from annihilating, and then you bring it somewhere else, and then you can release that antimatter to get energy out. Was on a live with a mathematician. She had a pretty cool algorithm she made. Okay, cool. Are we inside a black hole? I suspect not. I think that if general relativity is true, then we shouldn't be able to see the rotation due to, yeah, if general relativity is true, then even if the black hole that we were supposedly in was rotating, we wouldn't see additional biased rotation inside of our universe. JWST just found a super redshifted object, so is the universe even older? No, not really. So redshifted things can, even in principle, redshifted things can't be older than the universe, like can't be older than 13.8 billion years, even with our current models. If only because redshift gives you an age that depends on, or redshift gives you an age, and that age is always less than 13.8 billion years. What's your words per minute typing? You may be the fastest typist on YouTube. If I'm trying hard, like 180 or 190, but I probably average around 120. Why is spin consistent between different types of particles? Well, it's not. Like photons have spin 0, electrons have spin 1/2. Sorry, photons have spin 1, electrons have spin 1/2, the Higgs boson has spin 0. In a Kerr black hole spacetime, why does the ergosphere allow for negative energy orbits? Yeah, that's too complicated to explain in a live, and it requires doing some math. But essentially, a way that you can think about it is that within the, like inside the ergosphere, you're in some sense moving faster than the speed of light relative to some distant observer. And so that should at least suggest that something weird is happening. About to start an undergrad physics degree next week. Any tips? Go to office hours. It'll help. Can you give a physicist's perspective of what time practically is? Yeah, time is what a clock does. In Switzerland, are all types of cheese called Swiss cheese? Probably. We locally decrease entropy, so couldn't we eventually do that to everything in an instant with tech? No. And life isn't special about locally decreasing entropy. The thing is in order to decrease entropy, you have to increase entropy somewhere else. Do you think interstellar travel would ever be possible, not any time frame, just in general? Yeah, sure. Galactic formation occurred as early as 300 million years after the Big Bang? Sure. We don't really understand early universe galaxy formation, so there's no reason to think that that's impossible. Is FTL realistic? No. Would an object with negative mass be able to exceed the speed of light? No. Could have imaginary mass, but not negative mass. Does the wave function represent reality or just our knowledge of it? That's a philosophy question. How would I go about learning more physics myself without a degree? I really love the topic. I mean, you could get some textbooks if you want to actually learn physics. Otherwise, just read things like A Brief History of Time by Stephen Hawking. Since you're a physicist, what would be the best way to blow down and protect an egg from a certain height? I don't know. I'm not an engineer. How's the job market for physics? It's hard. Could we transfer our consciousness into a robot? I don't know. Ask a neurologist. Can quantum entanglement ever be used to transfer energy, not just information? Not faster than light. And not energy either, I don't think. Well, yeah, you can't really transfer it. Now, what can happen is you can measure a low energy state here and a high energy state there, but that's not really a transfer. Can you explain why the existence of deuterium nuclei explains the impossibility of neutron-neutron, proton-proton states? Well, one way to think about this is that, so I'm speculating here, I'm just thinking off the top of my head. So a proton-proton state is probably forbidden, if only because the strong nuclear force is just overpowered by the weak nuclear force, or by the electrostatic repulsion. However, you could imagine having a neutron-proton or a neutron-neutron state, but we know that the neutron-neutron state would necessarily have more, be a high energy state than a neutron-proton state. A neutron-proton state, protons weigh less than neutrons. A neutron-proton state would have the exact same binding energy. There might be a spin-spin interaction that I'm missing, but we can treat that as negligible. And so it would be energetically favorable for a neutron-neutron state to decay into a neutron-proton state, just because there's energy left over that it can get out of that. And so it seems like if you have a neutron-proton state that's stable, then it would, or that's even bound, then it would make sense that you wouldn't be able to have a neutron-neutron state because there's a bound state that's neutron-proton. Now, that might not be the correct answer, but that'd be my first guess. What would happen if a Kerr black hole was surrounded by a perfect mirror and a laser beam was arranged so that only part of it entered the horizon while the rest kept reflecting? I don't know, I'd have to work out the details on that. I mean, like, generally perfect mirrors are a problem, but, you know, it's like not, but if you surround it and then you have, and then what else? We have a laser beam arranged so that only part of it enters the horizon. I guess part of it would enter the horizon, and then the stuff that bounced off the mirror, some of that would enter the horizon, right? Like, some of it would just keep entering the horizon, and so you just grow the Kerr black hole until it encompasses the horizon, I guess. Is Ask an Atheist just for views grabs, or is there going to be an outcome where you stop asking? I don't do Ask an Atheist, I do Ask a Physicist. Do physicists think light is the fastest thing? Yes. How do semi-direct fermions have mass in one direction, yet massless in the perpendicular direction? I have a video on this. The point is, it's not a fundamental particle that does this. This is a quasi-particle, and so you have a crystalline structure that has an asymmetry. It's not, the crystalline structure is different in one direction as relative to the other direction, so you can have oscillations of a certain kind, which we call massless, in one direction that you can't have in the other direction, and so you have a massive oscillation in the other way. But I do have a video on it, so go check that out. It should be fun. If space-time is geometric and can deform and reform, does that imply both the stiffness, tension, and a tolerance? Yes, you can talk about the stiffness of space-time. And it's very, very stiff. Any thoughts of finding dark matter within the Milky Way? Yeah, there's dark matter. If dark matter exists, then it's everywhere. How does something with no mass have speed? It still exists. It still has a spatial location. Hi, can you recommend some textbooks for beginners for physics? Yeah, University Physics by Young and Friedman, or University Physics by, is it Sears and Zemansky? I don't remember what the first guy's name is. What right now would you consider to be the biggest debate among physicists? There probably isn't a single biggest debate. I mean, there's always questions about like what dark energy is, what dark matter is. But you know, there's no one single biggest debate, I don't think. Why is the moon locked? Yeah, this is a good question. So the moon is tidally locked, meaning that the same face always faces the Earth as it rotates. It doesn't mean it doesn't spin, it just makes one spin every time it goes around the Earth. So imagine that the moon wasn't tidally locked. That means that it would either rotate too fast or too slowly, so that it wouldn't keep up with the Earth. Now, because the Earth is a big mass, because the Earth has a like large gravitational mass, it pulls on the moon and it kind of stretches that out so that it's facing the Earth. But if its spin wasn't exactly matched with the rotation around the Earth, then that would mean that its stretched bit would kind of, it would turn, it would be stretched in a direction that's not facing the Earth because it's rotating too fast or too slowly. And so the Earth's gravitational pull can essentially apply a torque to that stretched moon and torque it back so that it's facing the Earth again. And you only reach equilibrium when it rotates exactly once per orbit. What's your take on the future of quantum computing? Well, it currently exists. We have quantum computing. I don't know if it'll ever be like a household thing because classical computing is really effective. Quantum computing is only better at a certain type of computation, but who knows? If you were able to travel close to the speed of light, how would we solve the issue of relaying the information gathered against time dilation? Well, you would send the information and it would just get to your destination with big gaps. Are you skeptical of QED or QFT? Not really. They're like the most accurate theories that we've ever developed. How likely was life to happen in our universe? Like, are we very, very small percentage chance? Maybe not. It's possible that life also happened again on Mars. And so it might be very, very common. Do multiverses exist, or is it just a mathematical concept? We don't know. If the Big Crunch is possible, couldn't we advance our tech to aid in the process somehow? Not necessarily, no. Do you believe a person can control the wind? I guess, yeah, it's called a fan, right? Hi, also physics PhD student. What new experiment telescope are you most excited for? LISA, the Laser Interferometry Space Antenna. Also, I'm not a physics PhD student, for what it's worth. I haven't been a PhD student for several years. Where did the singularity come from? I don't think the singularity is real. In fact, and I'm not alone in that. A lot of physicists don't think singularities are physical. How close can we get to a black hole and not go in? You can get infinitesimally close to the event horizon, but you can't go any further. What is the precise microphysical origin of dark energy? Nobody knows. Nobody has any idea. Is there any progress being made on better understanding gravity? Yeah, every day, all day, every day. That's my area of research. In fact, it's one of my areas of research. Blitz, do you have any comment regarding the rumors of you having a sexual relationship with Ian? Is there any truth to these allegations? Well, considering that we live on opposite ends of the country, and I'm like straight, I don't know about Ian. I don't know what Ian's business is. Nope. I feel like that was a troll question, though. It's a funny question, but it's a troll question. Also, weird to call them allegations, right? Why can't we see outside the observable universe? Well, if we could, then the observable universe would be bigger, right? but more seriously, the universe is expanding, and there's stuff in the observable universe. Sorry, there's stuff in the universe as a whole that is so far away that the distance between us and it is growing faster than the speed of light. So the light could never get to us. It doesn't have enough, the distance is too great. Did that actor guy discover hypersymmetry fractals? No, of course he didn't. Do you believe in a theory of everything? I don't know what you mean by believe in. I don't think that any of the current proposition or proposals are correct. How do you define stuff? I don't know, like the things that pens and rulers and batteries are. If you don't believe in singularities, then what do you think is the core of the black hole? I suspect it's an ultra-dense core of some kind of matter that we don't understand. Are you aware of the applications of group theory to physics? I have a PhD in abstract algebra. Oh yeah, there are tons of applications of group theory in physics. Like so many. Like the standard model is built on group theory. Well, it's built on representation theory, which is group theory, right? What is the wave function collapse and what consequences does that have for us? Well, the wave function collapse is a proposed explanation for why we make the observations that we do when we measure quantum systems that are in a superposition. So imagine that you have an electron that's in a superposition of up and down. So it's in some sense both simultaneously, but then you go and you measure it and you only ever get one outcome. You either get up or down. One possible explanation for that is that when you make a measurement, for some reason that causes the superposition to collapse and to just pick one of them randomly. Now, I don't actually think that this is a thing that happens. I think there's a better explanation which involves many worlds, but it's one plausible explanation. If dark matter and dark energy exist, could there be dark light? Yeah, there's this idea called the dark sector, which would plausibly explain dark matter, and that would include things like dark photons. I have a video on it, so you should go check it out. Do you have the flu right now? I don't think it's the flu. I tested, and it's not the flu. It's not COVID. I think it's just an extended cold. But yes, my voice doesn't sound normal. What happens if you feed a black hole only low-carb tachyons? Are wormholes physically real and stable, or purely theoretical? They are purely theoretical. I would even say hypothetical. We don't have any reason to think that they can form. How often do you do these questions on live? I'm at work and would like to ask more questions. I do them every Tuesday and Wednesday. Can you explain the relationship between relativity and quantum mechanics? So special relativity and quantum mechanics merge perfectly well. Special relativity and quantum mechanics, when you shove them together, you get quantum field theory, or also known as relativistic quantum mechanics. And that's really, really great, and it's a great theory. The trouble is we don't know how to merge general relativity, which is a theory of gravity, and quantum field theory. We just don't know how to do that. Does that one star that spins 24% the speed of light produce photons that travel 24% faster? Explain the obvious reason. The answer is no. Yeah, so it doesn't produce photons that travel 24% faster. Photons always travel at the speed of light. What happens is that they get blue shifted. So they get more energy, but more energy for a photon doesn't mean faster, it just means shorter wavelength, higher frequency. Sorry about that. What are your thoughts regarding 3i Atlas? It's a comet. It's a weird comet, but it's a comet. Do you know why the universe is expanding? Well, the universe is expanding in part because of inertia and in part because of dark energy. Even if there was no dark energy, the universe would have still expanded and then recollapsed, just because of the inertia from the initial expansion from the Big Bang. However, the universe's expansion is accelerating. It's not slowing down, and so that would lead us to suspect that, in fact, the universe has an additional factor that we call dark energy, which is driving the accelerated expansion of the universe. Could you hear a supernova in space if you were right next to it? It depends on how close right next to it is. I suspect that if you were close enough to hear it, you'd be close enough to die. Is the universe definitely deterministic? No. But some of our best, like, it all kind of hinges on whether or not quantum mechanics is deterministic. I lean towards yes, that quantum mechanics is. If quantum mechanics is deterministic, then we have good reason to think that the universe is. If quantum mechanics is not deterministic, then we have reason to think that the universe is not deterministic. Can you explain the Doppler effect to me? Yeah, so imagine that you have a siren, or an ambulance rather, and its siren is going. But instead of sending out like a continuous sine wave, like meow, you know, like the siren sound, instead it just sends out a puff of air every tenth of a second or something like that. Now that's basically what a sound is. If you send out a puff of air every tenth of a second, that's a 10 hertz wave. That's a 10 hertz sound wave. But if the ambulance is driving towards you, then you would get the first puff of air, and then the second puff of air would have been emitted closer to you because the ambulance is traveling towards you. And so the second puff of air would have taken less time to get to your ear. So it would seem like it was less than a tenth of a second between puffs of air. And so if something's driving towards you, the frequency seems like it goes up. The time between puffs, the time between peaks gets smaller. And so you can get the Doppler effect that way. And then it's similar if it's traveling away from you or if you're traveling away from it. You got any cats? Yes, I have one cat. Any discoveries within physics that have caught your interest recently? I'm really behind on looking at the recent papers, so I need to go look at those today. That's on my to-do list. The atmosphere of a star is the loudest sound known. Yes, stellar atmospheres are very, very loud. The question is can you survive to get close enough to hear it? Why do photons transfer momentum even though they don't have mass? Because they have momentum. That's why. They have momentum. They don't have mass, but they do have momentum. If you're asking why they have momentum, well, it's just because momentum doesn't require mass. That's just a property of momentum. Why does light change between particle and wave? It doesn't. Light is always a wave. It just sometimes is a wave that is particle-like. Why does my gas... Can you tell gas pressure that rockets work in space, please? Oh, I've told him that like half a dozen times, probably. Maybe more. Is there a universe simulation? Can we detect the computational substrate running it? No, I don't think so. Where do you read recent physics papers? Go to archive.org. A-R-X-I-V. .org. Do quantum mechanics validate simulated reality theories? No, they don't. How would a Majorana fermion go about annihilation? Majorana fermions are their own antiparticles, so they would, you know, if they are their own antiparticles, that is, then they would annihilate in the sense that they could, in principle at least, give rise, well, they can't be charged. They don't, so I don't think that they would, actually. They're just their own antiparticles because all of their charges would be the same. It would be the opposite of themselves, which is 0. No, it's not this. Yeah, I'd have to. God, so don't trust that answer. I'd have to go read up on Majorana particles again because it's been a long time. A cosmic edge defies intuition, forcing us to confront whether nothingness or something else. Nobody thinks that. No physicists think that the universe has an edge, really. Rather, the universe is either infinite or it's finite with no edge, like the surface of the Earth. If light is always a wave, does that mean it's just basically everywhere and we're just perceiving the changes in it? Well, the electromagnetic field is everywhere, yeah. Explain sonoluminescence. So we don't actually have a good theory for this. I made a video on like the best theory that we currently have, but we don't have like definitive theory. So go watch the video if you're interested in more details. But the rough idea is that you have a thermodynamic process where if you compress something down very, very quickly, it'll heat up a lot. And that heat's going to cause various ionization procedures or processes. So you have a bubble. It's oscillating super, super fast, super, super high pressure. It collapses the bubble. The bubble collapses down to a very, very tiny volume very quickly, which raises the temperature a lot. And when that temperature gets high enough, it ionizes the air inside the bubble. That air then recombines and emits light. And that's roughly the idea. what do you think the shape of the universe is? I suspect it's either has the topology of a 3-sphere, so it's like a three-dimensional it's like the three-dimensional version of the surface of the Earth, or it's infinitely large, and has the topology of the of R3. That'd be my guess. Is it true that that bigger atoms reacted similar to electrons in a double slit experiment? Yes. Yeah. How did random fluctuations happen in the Big Bang? Which random fluctuations? How long before we achieve matter-energy transfer? Matter and energy aren't the same thing. Mass is a kind of energy, though. How are photons created? Like, why does the light spread everywhere and are not finite? Well, look, so the thing is photons are not like little bullets. Photons can be spherical waves that expand outwards. It's just, and then if you have a detector, you have a probability of detecting the photon being where you are. So like it can expand outwards like in a sphere. They're not like little bullets. Photon is no matter but energy. A photon isn't an energy, or a photon isn't energy. Energy is not a substance. Matter can be turned into energy because neither can be destroyed, only changed. No, matter can't be turned into energy because nothing is made of energy. Nothing is energy. Now, what can happen is you can have matter turn into photons, but photons aren't energy either. Photons are electromagnetic waves, and they have a whole bunch of properties. One of the properties includes energy, but it has a whole bunch of properties. Why do different colors have different wavelengths? Well, it's more that there are different wavelengths, and our eyes tell the different wavelengths apart by interpreting them as different colors. What is energy? Energy is a property of a system that is conserved in certain scenarios. If the universe wasn't infinite, what would the outside be called? Well, there wouldn't be an outside. That's kind of what the universe, okay, it depends. If you believe in inflation, if you believe in like multiverse inflation, then there could be an outside and it would just be like more like de Sitter space, but like kind of empty. But if you don't believe in inflation, then there wouldn't be an outside. It's just the whole universe. Is it better to say that mass contains energy? No, not really. It's better to say that mass mass is the energy that a system has at rest. How would you explain, oh, I already answered that. How would you explain the double slit test in consciousness? Well, consciousness in the mainstream interpretation has nothing to do with the double slit. All that's happening with the double slit is that you're interacting with the system in order to detect which slit it goes through. And by interacting with it, you're affecting it. Are singularities real or signs of a theory breakdown? I suspect the latter, that they're signs of a theory breakdown. Can you explain why the Hamiltonian Schrodinger's equation refers to eternality of the universe? Yeah, so look, there's basically, the point is basically this. The Schrodinger equation is a first order differential equation in time. And what that means is, like mathematically, any state of the universe could be wound back forever, right? There are some issues with singularities. If you assume that the Hamiltonian is regular, then you could wind back the state of the universe forever. So assuming the Hamiltonian is sufficiently well behaved, which we have good reason to think that it is, then you can wind back the state of the universe forever, mathematically. Now, the point is that the universe would be exactly as it were if the universe did have a past, if the universe was past eternal. And so so you could say that, well, maybe this just means that the math goes back forever, but that doesn't mean that time actually goes back forever. But my contention is that there's no distinction between the two. Because if the universe is exactly as it would be if the universe went back forever, then that just means that it did go back forever, right? That'd be like saying, well, the universe is exactly as it would be as if last week existed, but last week didn't exist. But yet I still have all of the memories of last week. Oh, but last week didn't exist. The universe is just exactly as it would be as if it did exist. Well, then it may as well just exist, right? From Yoshkin with the €6, thank you. Can you tell me what you think about lots of small black holes as a candidate for dark matter? I think it's good, but it's being more and more heavily constrained, and we've never detected them. By the way, I should say, if you want your question to be answered definitely, send a super chat, because super chats get first dibs. That's what on YouTube, of course. Is time not actually linear? Well, it's kind of bendy, but it depends. Would you ever hop on a Jubilee podcast? Would you love your content? In principle, yeah. Depends on what the topic would be. Does the Andromeda paradox prove we're in the process of expansion? The Andromeda paradox doesn't really have anything to do with expansion. All it has to do with is relativistic or relativity of simultaneity. How does one send a super chat? You have to go be on YouTube. Is time just gravity? No, gravity is just part of time. Or rather, part of gravity is time. Do I need to know Calculus 3 to take engineering physics 2? You probably do, yeah. Are you more happy that double slit created so much interest in physics, or more annoyed that it misrepresented and misinterpreted so much? The latter. Honestly, the latter. Do I need to know Oh, I already answered that. How did first atom come? Yeah, so 13.8 billion years ago, the universe was really, really hot. You had a quark gluon plasma. And so, yeah, you have a quark gluon plasma. The universe cools down. Some of those quarks and gluons bind together to form protons. And then the universe cools down some more. You get some neutrons. And then, no, actually, that's not the right order. You get some protons. And then the universe cools down some more. And then you get some neutrons, and those protons and neutrons combine to form proton and hydrogen and helium nuclei. And the universe cools down some more, and those hydrogen and helium nuclei grab electrons, and those are what atoms are. Is physics just a study of gravity? No, there's a lot of other stuff going on as well. Jubilee is divisive garbage. I only watch when Parker and Dean are on, or Blitz. I'd pay to see that. Yeah, maybe they could do a 20 flat earthers versus a scientist or something. That'd be fun. What are people saying about America to you in the country you live in? I live in America. Where does the neutrino fall in at? The neutrinos almost certainly existed for basically the whole time. They're very, very weird particles. They don't really do much. Why does the moon don't spin and every other moon or planet spin? The moon does spin. It just spins once every orbit. I'm glad you enjoyed the horizontal stream. I was going to try to get it set up this time, but I wasn't able to figure out how to do a horizontal stream and a vertical stream simultaneously on YouTube for Ask a Physicist. And I feel like the vertical stream does better for Ask a Physicist because people might be watching on their phone and want to type in their answers. What happened to your real human brother? He's been busy. We want to know how Big Bang created matter from a high intense energy singularity. I don't think the singularity existed, and a lot of people don't. Derive from first principles the mass of a glue ball? No, I refuse. Keeping it secret. If matter can't be created or destroyed, how is there matter to begin with? Matter can be created and destroyed. If you own a banana, then there is matter being destroyed in your kitchen. How can you tell whose time is slower? Because for both of you, you were still and the others moving. So what matters in this case is whether or not whoever did the acceleration is the one whose time will move slower. Is science infinite? I don't even know what that question means. Three Atlas, it's a comet. According to my friend Halley's comet having a tail is proof for young Earth creationism. Yeah, that's because they think that Halley's comet would have been coming around every 70-ish years for 4 billion years, but that's just not the case, right? Like we don't have any reason to think that it's always been coming around, right? Does the expansion of space happen everywhere, like also on Earth or even within ourselves? No. It only happens where the gravitational or where the binding energy holding things together, whether gravitational or electromagnetic, is weaker than the kind of negative gravity pushing things apart from dark energy. From Matt Mulkeen with the $5. On an earlier show, you said that of the Star Trek's tech, subspace would be the most implausible. Are anti-gravity machines equally implausible? Oh yeah, probably. I forgot that there's anti-gravity on all of their starships because it's just so natural, but yeah, also probably equally implausible. Do you think an average IQ person can get a degree in physics? In principle, yeah. It might be hard though. Why is the discovery of the Higgs boson so significant? Well, it was theorized back in the 60s and 70s, and its existence was kind of necessary to complete the standard model of particle physics. So if it didn't exist, then it would have been a big deal, and the fact that it does exist is also a big deal. So you don't believe in the Big Bang or equals MC squared? Don't explain creation of matter? No, neither of those explain the creation of matter. Fear's interaction with the $10. Which Star Trek tech is more achievable? The replicator, the transporter, or the warp drive? The tech doesn't have to work exactly as on the show, but should produce the same results. I suspect it'd be the replicator. The replicator seems like it's, at least within the line of like known physics, you basically just are kind of manually coding up you're manually coding up like atomic structure, which I guess you could do in principle. Could you explain the Hilbert place? What Hilbert? The Hilbert place? I don't know what that means. Hilbert space? Maybe? Yeah, could you explain the Hilbert space a little bit? Yeah, Hilbert space is a mathematical space. You can think of it as like the place where vectors live. So vectors are arrows in a plane, or arrows in a, they're arrows, they're things with magnitude and direction. And then it has a little bit of extra stuff tacked on. It's a complete metric space, and it has an inner product induced by the metric. It can be infinite dimensional and so on. How well can we detect space debris coming into our atmosphere? How fearful should we be of getting hit by satellite parts? We can detect it pretty well, so I wouldn't be too worried. If you had unlimited funding, what experiment would you run to test the limits of physics? It's not a matter of funding, it's a matter of resources, right? Like, we don't have enough resources to build a particle accelerator the size of the solar system. There's just not enough stuff on Earth. But that's what I would like to do. Y'all, I know I've only been live for an hour, but I just don't feel great. So I think I'm gonna end the live and just chill for a bit before I get to work. Thank you guys for being here. Sorry for the short live, and hopefully I'll be feeling better and we can do a longer one tomorrow. In the meantime, make sure to join the Discord server. There's links in the various places, Linktree in my bio on TikTok, the description of the YouTube channel, and I'll see you guys later. Take care.